how you would do it in real physics. You probably get an equation for this line, and then you take the derivative at a certain point, plug in certain bounds, and then you have the velocity. The angle alpha, I mean, I don't even know what that is. Alpha. What's alpha? Probably the angle of rotation, like if you have an axis here, and like you have some angle here, this would be alpha. Oh no, alpha, that's right. Alpha is acceleration. Think of a fish swimming, it's accelerating. Alpha refers to acceleration, which means alpha, if you integrate alpha, you're going to get W. And if you integrate W, you're going to get your position, which is given by theta.
Okay.
So basically, in real physics, you have like your x, you have your v, and then you have your a, right?
Mm-hmm.
You have your position, velocity, and acceleration. In rotational kinematics, they're simply called something else. X is now called theta, your velocity is now called omega, and your acceleration is called alpha. And just think of it like that. And there are equations, like real simple equations, to where you can go from the x to the theta, or from the theta to the x, and so forth. But basically, every equation that you learn in kinematics still applies in for rotational kinematics. You just have to make like a slight tweak, because you're no longer going in a straight line, you're going in a circle, which means, like, for example, you say the circle is a circle like the unit circle, right?
Yeah.
And if you travel like 2 pi, how much distance have you actually traveled?
Distance or displacement?
Displacement. What's your displacement?
0.
0, exactly. So things like that are different in rotational kinematics. There's only a certain amount. There's only a maximum distance you can go versus linear, where you can just go on in a straight line forever. So that's the main. You notice that theta, omega, and that alpha. Just think position, velocity, acceleration, but in terms of a circle.
Okay, and then those tangent lines. What are those again?
Like this is the angular velocity. These tangent lines are say this is going in a circle, and you stop it. Like you freeze time. That's the direction the velocity is actually going in, because you can't travel in a curve. You can only ever travel in a straight line, and a circle is basically made up of a bunch of straight lines, right?
Mm-hmm.
Like little tiny straight lines. So if he might ask you, like, we'll bring that up somehow. It's usually called like instantaneous velocity, which is that. Like, just at that one point, just remember that it's always tangent. But if you unfreeze time, then it's a circle. But if you freeze time, and right at that point, it's the velocity tangent. And then you'll do some stuff where, like, you'll have to take probably, like, perpendicular, and your trig is going to be involved. Because, like, see, like, to this arrow, and then you'll have a triangle, and then, holy shit, this is suddenly a right angle. So then you can do trig to it to find distance, or your distance traveled, or the magnitude of your velocity. So terminology, magnitude is, right?
Yeah.
Like how much something is. And like I said, you have your 3 new terms, which are really the same 3 old ones that you had. You add an element of, what is it? There's simple equations. I remember it in my physics class. I can't remember them, but it's like, just like x is equal to something, 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 and then you get theta. It's like it has like equations of like 3 terms. They're not hard at all. But just in case you need to convert between 2 or anything like that. So then that's just it. Just think of it in a circle. You're moving in circles. Yeah.
All right. Thank you.
So don't let Lambert confuse you.
It happens a lot.
It's okay. Just find a simple way and stick to that way, and like whenever you get stuck, just go back to that simple way, and then if you really, really get stuck, then go back to just normal straight line kinematics. And when it makes sense in line kinematics, then you can go back to rotational and it'll make sense as well. Any other